Did you all get the data that I mentioned before? So basically now, the exercise is just to try to image that data set. Yeah, I wanted to mention that the gain parameter that I explained at the very beginning in the Hopborn clean, in the original paper, remember that we don't extract the full, when we detect a point source, we don't extract all of it like this. We take just a fraction, just to be a bit conservative. So in the original paper, the gain was defined at 1 minus gamma, but here in clean is defined as a fraction. So gain of 0.1 means that I'm only going to extract 10% of the point source that I have just found. Okay, this is very conservative. You can, if there are very extended sources, you can put it lower. And if there are point sources, you can make it larger, but it's not very recommended because then you will see your residuals will look very, very bad. Unless you are sure that there is just one point source there. Perfect point source, then you can increase that gain parameter. And yeah, the idea now is that you take that data set that is very light. It's 100. When you decompress, perhaps it's a bit more, 300 or something like that, 300 megabytes. And then you try and play with the making images. It's just the TW Hydra disk. And you can use the, the CASA guides. Where did I put them? Sorry. What is the imaging? I prepared a slide for the imaging. So basically is that you follow the CASA guides. Sorry, I thought I had it in a slide. Maybe I killed it. I will put it now. So if you look for the TW Hydra CASA guide that we were working on for the analysis part, remember? We were doing the moments. We were doing the analysis of the moments. So at the beginning, there is a section which is called image and self-calibration of the continuum. So I have shared this continuum data set with you. So you can image it following the guide. Can you get it? No. Yeah. I thought I had it in the website, but it's like self-calibration. I deleted it from. Is this, you have it in the slides of session 6. I can share again the link with you. Do you have it there? The slides of session 6? It's very straightforward. If you Google CASA guide TW Hydra, sorry guys, I had put the calibration but not the imaging. You will get this. This is the one that we were looking into the other day. And here you have two parts. One is the calibration tutorial that you can take a look if you want to see how all the calibration steps that I explained before can be performed. And the second part is the one that we are interested in now. The second part, we were already working on it for the data analysis, but just at the very end, just for the moment analysis. But now, what I want you to do is try to image the continuum and perhaps try a couple of steps of self-calibration if the imaging works in the computers. So the data set that I have shared with you is called TW Hydra continuum cont.ms. This comes from, the step before from the calibration, in which you basically average all the channel maps into one. Okay, so you can start by making this cleaning step. There is a trick to extract all the CASA Python commands from a CASA guide. There is somebody created somebody created a Python script that collects all the CASA commands from a wiki, and you can try to download it. If you go to the very end, you can try to download this extract CasaPy, CasaScript.py. If you are very lazy and you don't want to copy paste, this is basically what I'm meaning. But it's better if you go and step by step and copy paste, because there is also text in between that you may want to read. Okay? But yeah. I will put the full script in my home as well, perhaps. No, I can put it in the, I will put it in the activity, okay? Let's see. Okay. In principle, should be like something like that. Whatever. It doesn't look quite. It should be if you don't have like atmosphere line, should something like that. Okay, this would be the original data cube. We have lots of channels, and we have signal at every channel. Our final goal is to make an analysis of the properties of the line. But this line is on top of a continuum. Okay? So what I need to do is in order to do the steps that we were performing for the analysis, what I need to do is subtract the continuum, and then I can already image the line. See? So then, ideally, I will check with PlotMS. I would check frequency or channel versus amplitude, and then perhaps I could already see the line, and then I could see which channels to use for subtracting the continuum. See? Okay. This step that we are doing now, it's one more. It's to have a much better image of the line afterwards. Okay, because this continuum is bright enough. It's not like the SDP81. When we looked into PlotMS, it was basically flat, right? We didn't see any line or nothing. Here, this continuum is bright enough. So what I do is I take first, I extract the line-free channels in another data set, and I save them in the file cont.ms that I sent you. Okay? Here, I don't have the line. I just have the background continuum of the source. Okay? I could do already science with it, because the continuum is telling you properties of the target. You can get temperature, etc. Okay? I could work already with the continuum. But my goal is to extract it as in the best way as possible, and also to have a very good model of my target, so the final images in the cube look good. So now we have the continuum subtracted. And the part that I'm suggesting you to do, because the continuum is, this file is much smaller than all the channels for the line. In this continuum, they have done this extra step of self-calibration. So the data has already been calibrated for the primary flux calibrator, okay, and also for the amplitude and phases with a secondary calibrator. But still, I can do it better. Why? Because this source is strong in the continuum. So in the ALMA guide that you can see, that you can follow there, it's basically image the continuum for the first time, one image. Then calculate phase solutions with GainCal. You will get a table of phase solutions that some of you are already checking. Then you can apply that table to the file and make another image, and then make another GainCal. And perhaps at the end make an amplitude and phase GainCal. And then you have a table, or table 1, table 2, or table whatever n, which are phase and amplitude corrections for the continuum to look super nice. Okay? So then this way you get rid of extra phase disturbances, etc. With those tables, I'm able to make a very nice image of the continuum. I can apply those tables to the full data set, and then I image channel per channel the channels that contain a line. And that was the cube that we were analyzing. So, sorry, forgot something. I apply this to the full data cube. I subtract the continuum, and then I image the line. Okay? And that was this part was the one that we were analyzing the other day, that we were looking into the moments, moment 0, moment 1, PV diagram, etc. So it's basically, you can just subtract it from the beginning. But here, they made the extra step of imaging the continuum to do a self-calibration of the source to finally get better images of the line. Okay? So I hope it's clear now. You can go. No, I don't know. What time is it? 12. Okay. Then I need to go.